Let's take a look at some special angles of triangles. One of the most important things that you need to know about a triangle is the triangle sum theorem. And the triangle sum theorem states that the sum of the measures of the angles of a triangle is 180 degrees. Doesn't matter if your triangle is acute, obtuse, or right. If you add the three angles, you will always get 180 degrees. So we're going to start by finding some missing angles. So for number one, it's pretty straightforward. You have two measures of 53 and 78, and we're looking for that third missing angle. So to find all of them, we're going to add them together. X plus 53 plus 78 equals 180. And you can go ahead and actually add 53 and 78 together, which is 131. And then we're going to need to subtract 131 from both sides. 180 minus 131 is 49, so x would equal 49. For number two, we can see that it's a right triangle. The way I know it's a right triangle is because it's got the little mark in the corner. Just because it looks right doesn't mean it's right. It needs to have that mark or say 90 degrees there. So that means that we do know that that is 90 degrees. We have one angle marked x. Now, what I do know about those two angles is that those angles are congruent. And the reason I know that is because we have that the two sides are congruent, making this an isosceles triangle. And one of our theorems was that if the two sides are congruent, so if it's an isosceles triangle and the legs are congruent, then the angles opposite those legs or those base angles are going to be congruent. So what that means is I know this other angle is x. So to find what x is, I'm going to add all three angles, so x, x, and 90, and set that equal to 180. I'm going to add x and x, which is 2x, and then I'm going to subtract 90 to the other side. And I'm doing this from an algebraic approach. I understand that most of you can go to your calculator and type things in, but I am going to want to see work because if you make a mistake in your calculator, I'm not going to be able to see what your mistake is. But if you at least set this up algebraically, I can follow your work and give you some credit. So that gives us 2x equals 90. Divide both sides by 2. So x is going to be equivalent to 45. So both of those missing angles would be 45 degrees. Couple more problems like that. So 3, we've got a little bit more involved. We don't have any specific degree measures at this point in time, but we do have some algebraic expressions replacing the angle measures. So I'm still going to do the same thing. I'm going to add them up. So 3x minus 11 plus 6x minus 9 plus x equals 180. I'm going to combine my like terms. So I've got 3x plus 6x, which is a 9x, plus x is going to be 10x. And then I'm going to look at my constants. Negative 11 minus 9 is negative 20, equals 180. We're going to add 20 to both sides. So 10x equals 200. We're going to divide both sides by 10, and so x is going to be 20. All right, for our fourth example, we have x, which is over here in this bottom left-hand corner. And as of right now, we're missing another angle as well. So we're missing this angle right here. So I can't really find x until I find that angle measure. What I do know is that angle is a vertical angle to the angle opposite, which is this one right here. So if I can find that angle, then I can find the vertical angle, and then I can find x. So I'm going to concentrate on the right side, the triangle that's on the right side of this picture. I do know that it has two angles that are x and 75, so I'm just going to label this angle y just to make things easier. So I'm going to find y first. So y plus 75 plus 67 together, those three angles should equal 180. 75 and 67 together is 142. And then I'm going to subtract 142, which is going to give me 38. So now I know that this angle measure right here is 38 degrees. And I also know that its vertical angle is 38 degrees. So now I can find angle X, because X plus 28 plus 38 should equal 180. 28 and 38 together is 66. And then I'm going to subtract 66 from both sides. And 180 minus 66 is 114. So X is equal to 114. All right, so we know that the triangle sum theorem does state that the three angles in a triangle add to 180. Because it's a theorem, that means someone had to prove it. Someone couldn't just say, oh, it's 180 degrees because I said so. There has to be a proof behind it. So that's what we're going to do. So in this proof, this one is a little bit different because we're starting by choosing to draw this line AD, which is right here. We're drawing it so that it's parallel to BC. And there's a reason, and you'll see as we do the proof why we choose to do that. When we draw line AD, it creates two angles, 4 and 5, that are on the outside of the triangle. But what we do know is that that angle 4 plus 2 plus 5 should equal 180 degrees because it's a line. So we're basically going to say that that's equal to 180 degrees. It takes kind of a second to get there because you can't really jump straight to it, even though visually I know that you guys can probably look at that and say, yes, 2 plus 4 plus 5 should equal 180 degrees. So I'm going to start by saying that 4 plus BAD, which BAD is 2 and 5 together, is 180 degrees, and that's your linear pair property. And then my next statement is going to be that BAD is equivalent to the measure of angle 2 plus the measure of angle 5. And this is a postulate that we actually haven't done, but it's one that's like, well, of course BAD is 2 plus 5 because those are the two angles that make that angle. It's called the angle addition postulate. And this is the only proof that we're doing that is going to actually use angle addition. But it is actually used in a lot of proofs, or it can be used in a lot of proofs. So then from there, what we're going to do is we're going to take BAD out in step 2, and we're going to replace it with 2 plus 5. So we're going to say the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180 degrees. So when we replace something, that is substitution. Okay, so now here is why we chose to draw AD so that it's parallel to BC. So what we've created is 4 and 1 and 3 and 5, which are alternate interior angles. And if you recall, alternate interior angles are going to be congruent as long as those lines are parallel. So that's the next statement that we're going to make, and that is because of the alternate interior angle theorem. If you can only fit alternate interior angles on there, that's totally fine. It doesn't really matter if you put theorem or postulate. It's not that big of a deal. So for step 6, I'm going to basically repeat step 5, but I'm going to say, well, since I know they're congruent, now I know their measures are equal, and that's your definition of congruence. Anytime you go from equality to congruence or congruence to equality, that's definition of congruence. All right, and then that final step, what I'm going to do is I'm going to take the measure of angle 4 and I'm going to replace it with the measure of angle 1 since they are equivalent. And then I'm also going to take the measure of angle 5 and I'm going to replace it with the measure of angle 3 because they're equivalent. And so when I do that, that gives me the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180, which was what I was trying to prove. And when we replace, that again is substitution. And that's it. Another important theorem related to angles is the exterior angle theorem. Exterior is referring to an angle on the outside of the triangle. And what the exterior angle theorem says is that an exterior angle is equal to the sum of the two remote interior angles. So if we're looking at this diagram, angle 1 is your exterior angle, and your remote interior angles are the angles of the triangle that do not touch that exterior angle. So that would be angle A and angle B. So the measure of angle 1 should equal the measure of angle A plus the measure of angle B. And we will do the proof for this theorem in just one second. So just a few examples of making sure that we understand how to use the exterior angle theorem. So in example 5, our exterior angle is x, and it is equal to the sum of those two remote interior angles. So again, exterior angle, remote interior angles are the angles that do not touch that angle. So that would be 62 and 73. So if I add 62 and 73, that would equal 135. So that would be a 135-degree angle. All right, for example 6, our exterior angle is x. Our remote interior angles, the angles that do not touch that angle, are 31 and 90 degrees. So to find x, we would add 31 plus 90, so that would make it 121. Couple more examples here. Number 7 is a little bit more challenging because we have to think about what these little measures mean. Okay, this is an indication that this is an isosceles triangle. And so if those two sides are congruent, then these two angles right here are going to be congruent. So we're going to need to find those angles first because according to the exterior angle theorem, x should equal the sum of those remote interior angles, which would be this angle right here and this angle right here. And we know that one angle is 90 degrees, but we do not know the other one. So the first thing I'm going to do is I'm going to find those missing angles. I'm just going to call them y to make it easier. So we have y plus 98 equals 180. I'm going to go ahead and subtract 98. So that gives me 2y equals 82. Divide both sides by 2. So those angles are 41 degrees. So let me write that in there, 41, 41. So now when I use that exterior angle theorem, x is my exterior angle. It should be the sum of the two remote interior angles, so the angles that do not touch x, so that's 98 and 41. So 98 plus 41, that means x is going to equal 139. All right, and then our last example, again, the remote exterior angle theorem says that this exterior angle will equal the sum of these remote interior angles, the ones that do not touch that angle. So this one has a lot of x's, so we've got 7x minus 15 will equal 4x minus 3 plus x plus 28. So we're going to go ahead and simplify that. It's 7x minus 15. On the right side, we have 4x and x, which is 5x. And then we have minus 3 plus 28, which is going to be plus 25. I'm going to subtract 5x from both sides to get rid of the 5x on the right. I'm going to add 15 on both sides to get rid of the minus 15 on the left side. So 7x minus 5x is 2x. And 25 plus 15 is 40. Divide both sides by 2. X is going to equal 20. So here is the proof that it shows why the exterior angle theorem exists. So we're going to start by using our triangle sum theorem, which is what we just learned a minute ago. And according to the triangle sum theorem, remember that means all three angles add to equal 180 degrees. So that would be the measure of angle A plus the measure of angle B plus the measure of angle 2 equals 180 degrees. In this diagram, I know that the measure of angle 1 plus the measure of angle 2 also equals 180 degrees because of the linear pair property. So what I notice here is I have two things that both equal the same. So if you have two things that both equal 180, that means they must be equivalent to one another. So I know, and this is going to be kind of long, measure of angle 1 plus the measure of angle 2 has to equal the measure of angle A plus the measure of angle B plus the measure of angle 2 by the transitive property. And now what I notice is that I have the measure of angle 2 on both sides of the equation that I can get rid of by subtracting. And when I subtract, what that's going to leave me with is the measure of angle 1 equals the measure of angle A plus the measure of angle B, which is the exterior angle theorem. So subtraction property is our last step. So this shows that the exterior angle theorem works in all cases. Okay, I didn't use any specific angle measures for A, B, 1 or 2, so it proves the actual theorem.